Good day, Math Buddies! Sir Sherwin here, your math instructor. Are you now studying rational algebraic expression? Are you having a hard time performing its operation, just like addition and subtraction? Are you having difficulty in finding for the LCD or least common denominator? Well, if you are worrying that, this tutorial will really help you solve your concerns. But before that, please don't forget to subscribe on my YouTube channel and hit the notification bell for more updated contents. First, let's define rational expression. It is an expression written in the form P over Q, where P and Q are real numbers and Q is not equal to 0. If we still recall in adding or subtracting fractions, wherein we can only add or subtract fractions if they are similar fractions, or fractions containing common denominator. This mathematical concept can also be applied in adding or subtracting our rational algebraic expression. But for today's video, we will be focusing only on how to find LCD or least common denominator of our rational algebraic expression. With this, let's try to determine the different steps on how to find the LCD or the least common denominator. First, factor each denominator. Express as powers any factor that occurs more than once. Second, list all distinct factors that appears in the denominator. When the same factor appears in more than one denominator, get only the factor with the highest power. Third, find the product of all these factors. These are now your LCD or least common denominator. This time, let's try to have our first example. Let's find the LCD of A over 12x and B over 4xy. To find our LCD, let's have the first step, and that is to factor each denominator. Here, denominators are 12x and 4xy. So possible factors of 12x are 3 times 4, that is for the factors of 12, and of course, x. So 12x can be written as 3 times 4 times x. While we can simply write 4 times x times y for 4xy. Next, we will list down all distinct factors of our denominators. This means we have 3 times 4, since 4 appears as factors of our denominator. So we will write 4 only once. Same as true with x. So we will write x once. And we will copy y. This means our LCD is the product of 3 times 4 times x times y. This is equivalent to 12xy. Therefore, the LCD of our rational algebraic expression A over 12x and B over 4xy is 12xy. To write our rational algebraic expression in their equivalent RAE with their common denominator, that is A over 12x and B over 4xy. So having their common denominator, which is 12xy, let's write their equivalent RAE. This means 12xy divided by 12x, that would be y, times A. So we have AY. And 12xy divided by 4xy, that is 3, times B, we have 3b. So this can be considered as the equivalent rational algebraic expression of our given example with their common denominator. With this, we can add or subtract this RAE. Let's have our second example. Find the LCD of x squared over x minus 2 and 3 over 2 minus x. Here, our denominators are x minus 2 and 2 minus x. Remember, these two binomials are considered to be different. But we can write the equivalent rational algebraic expression if we will have a common denominator. So first, our denominators are x minus 2 and 2 minus x. So we can write x minus 2 as x minus 2. But we can rewrite 2 minus x in the form negative x plus 2. Then, we can also factor negative x plus 2 as we factor out the negative symbol. This is equal to negative times quantity x minus 2. So if we factor out the negative symbol out of negative x plus 2, we have the remaining expression x minus 2, which is similar to x minus 2 of our first denominator. So our LCD would be the negative symbol and x minus 2. So therefore, the least common denominator of our given expression would be negative quantity x minus 2. And to write the equivalent RAE of our given example, that is for x squared over x minus 2, we will have negative quantity x minus 2 divided by x minus 2, we have negative 1. Times x squared, we have negative x squared. So this is considered as the equivalent RAE of x squared over x minus 2. While for 3 over 2 minus x, we will have also the common denominator negative quantity x minus 2. Since negative quantity x minus 2 is a result when we factor out our original expression 2 minus x, then we can consider that 2 minus x is equal to negative quantity x minus 2. So our numerator will be the same, and that is 3. So in this case, we can add or subtract these two RAE because they have already their common denominator. Let's have our third example. Let's find the LCD of m minus 1 all over 2m plus 3 and 3m plus 4 all over m plus 1. Here, if we are to notice, the denominators are 2m plus 3 and m plus 1. And there has no common factor between these two denominators. And to determine our LCD, or the least common denominator, that would be the denominators itself. So, the LCD of this given expression would be 2m plus 3 and quantity m plus 1. So this would be the LCD of our given RAE. To write the equivalent RAE of our given example, we will have m minus 1 all over 2m plus 3. Since our LCD is quantity 2m plus 3 times quantity m plus 1, let's try to divide LCD by the denominator 2m plus 3, that is m plus 1. So we will have m plus 1 times quantity m minus 1. In short, the equivalent RAE of our given expression m minus 1 all over 2m plus 3 would be this expression. On the other hand, equivalent RAE of 3m plus 4 all over m plus 1 with common denominator 2m plus 3 and m plus 1, that is LCD divided by the denominator m plus 1, we will have 2m plus 3 and copy our numerator 3m plus 4. So this can be considered as the equivalent RAE of our expression 3m plus 4 all over m plus 1. So this is considered as their LCD. Let's have our fourth example. Find the LCD of 2 over x squared minus 6x plus 9 and x over 3x squared minus 9x. At first glance, we notice that our denominators are different. Thus, we can say that probably the LCD would be x squared minus 6x plus 9 and 3x squared minus 9x. But, before we decide of what would be our LCD, remember our steps. First, we need to factor out each denominator. Here, our first denominator is x squared minus 6x plus 9. And it is considered a special product. It is an expression when we simplify square of a binomial. So x squared minus 6x plus 9 can be written into a square of a binomial. And that is quantity x minus 3 squared. Or we can write this one as quantity x minus 3 times quantity x minus 3. On the other hand, 3x squared minus 9x as our second denominator can be factored, because the factored terms of this expression would be 3x times quantity x minus 3. Here, we notice that x minus 3 is shared by our two denominators. Thus, the LCD of this given RAE would be 3x times the shared binomial, which is x minus 3, and the remaining binomial, which is x minus 3. Therefore, the LCD would be 3x times quantity x minus 3 times quantity x minus 3, or we can write this one as 3x times quantity x minus 3 squared. So this would be the least common denominator of our given rational algebraic expression. And to write our equivalent rational algebraic expression of our given example, first for 2 over x squared minus 6x plus 9 with common denominator 3x times quantity x minus 3 times quantity x minus 3. Since x squared minus 6x plus 9 can be expanded into square of a binomial quantity x minus 3 squared, therefore LCD divided by x squared minus 6x plus 9, that is 3x times our numerator, which is 2. While for our second expression, x over 3x squared minus 9x, again with common denominator 3x times quantity x minus 3 times quantity x minus 3. So since 3x squared minus 9x is the same with 3x times quantity x minus 3, so that is quantity x minus 3 times our numerator, which is equal to x. This means the equivalent RAE of our given expression is presented in this rational algebraic expression. And we can directly add or subtract our rational algebraic expression. Let's have our fifth example. Find the least common denominator of the following expressions: x minus 2 over x squared, 2 over 4x, and 5 over 8x cubed. So first, to find our LCD, all we need to do is to factor the given denominator. So our denominators here are x squared, 4x, and 8x cubed. So to write our first denominator, that is x squared, it has its factor x times x. While for 4x, we have the factors 4 times x. And for 8x cubed, we have factors 4 times 2 times x times x times x. Here, we noticed that 4 is shared by 4x and 8x cubed. X is shared by the three denominators. Another x is shared by x squared and 8x cubed. So, our LCD would be 4 times 2 times x times x times x. This means our LCD would be 8x cubed. So this would be the LCD or least common denominator of our given expression. And to write the equivalent RAE of our given expression, we will have x minus 2 over x squared, 2 over 4x, and 5 over 8x cubed with common denominator, which is 8x cubed. 8x cubed. Alright. So here, 8x cubed divided by x squared, we have 8x times quantity x minus 2. While for our 8x cubed divided by 4x, we have 2x squared times 2. And the third one is written as 5 over 8x cubed. Here, we can add or subtract our rational algebraic expression because they have the common denominators. And that would be our next content. This time, it is your turn. Let us try to find the LCD or least common denominator of our following rational algebraic expression. Number 1, 6 over x and 3 over y. Second, 25 over a, 16 over b, and 9 over c. Third, 3x over x squared minus 9 and 8 over 4x minus 12. Make sure to write the equivalent rational algebraic expression. There you have it. Hope you learned something new today. God bless us all.